We will now take a look at the RBD material fracture node to create wood splinters and wood fracturing. For this exercise, I will be using this 3D model from Megascans, but remember, since I cannot distribute the models with the files, you can use a simple geometry or whatever 3D model that you have. So first of all, I will dive into the geometry node, and just below this null, I will connect an RBD material fracture. Make sure to click on its visibility icon. And remember, by default, the material type is set to concrete. So before we change this, let's add an exploded view as usual, just to better see the pieces that will be generated. So of course, in this case, the concrete won't work for us. So let's change that first. In the material type, change the type to wood. And right off the bat, you'll notice that we have some nice splinters here. Of course, we can do better than this, but as we've seen earlier, to achieve this kind of splinters with the regular tools is not that straightforward. So let us go into the grain parameters. And probably here, the easiest way to explain how the wood works is changing the visualizing parameters. I'm going to look for the guide geometry option and turn on grains, which is what we're actually changing here. So you will notice that the grains will be created with a few intersecting planes and Boolean operations, just as we did in chapter 3. Now, the grain spacing is exactly the space that we have here between each of these planes. So if we increase this value, we'll have a much larger separation here. So in this case, we only have 2 planes. If we want much more detail, we could decrease this value. So now we will have much more cutting planes. So let me go back to the default. You can control and middle click on a parameter to set it back to the default value. Now the grain offset is a random offset that we will have between each plane. So the bigger this value is, the greater this random spacing will be. And of course, we have a seed value. If we don't like the distribution that we get, we can always change this number. Now, the grain noise is this noise that we get on each plane. So if we increase the height, we will increase this noise, something similar to what we did with the mountains up. So let's reduce this a bit. And you can also increase or decrease the element size. In this case, I will decrease it just a bit. So we have smaller mountains. And the grain detail size is basically the resolution in which each of these planes will be subdivided. So in general, the closer you're going to look into the object, the more detail you want. And if you have, for example, a very distant shot, or you don't need an extremely high resolution model, you can always increase this value. So let's take a look at the exploded view. And notice how, although we were cutting here with a few planes, we are not getting this separation or these pieces separated. And the reason why this is happening is that by default, the wood object is clustering the pieces. So let me click on the cluster tab, and you will notice that by default, the enable cluster is on. So for now, let me turn this off just to see the individual pieces. And here we can clearly see the cutting planes that we were using to generate these pieces. Let's now take a look into the cut parameters of the wood object. So first of all, let me turn off the exploded view. I will zoom into the object a bit, and I will change the guide geometry to cuts. So the cuts are also planes that will generate shatter cuts, but this time through the length of the object. And for now, let me go down into the splinters parameters and take the splinter length to 0. And I will go back to the exploded view. So notice when combined, the grains and the cut generate plenty of detail. So let me click on the node again just to be able to change a few of these parameters. I will go back to the grain and turn off grain for now. So here we only have the cuts. This will help me see more clearly these parameters. So the spacing, of course, it's the space between each of these planes. The larger the spacing is, the less planes we'll have, and thus the pieces will also be longer. Again, we have a cut offset, and this is a random distance between each plane. So again, if we increase this value, we will have larger random values between each plane. So this way we will have more uneven lengths of cuts. So if we bring this down to 0, most of these pieces will have the same length. I usually like to increase this value a lot. And let me again go back to my visualizers. If I increase the curve noise, I'm increasing the amplitude of this noise. And if I want to make the noise pattern smaller, I can decrease the element size. Now, if you notice, we have no splinters anymore. We just have these chunks of wood. The splinters are generated with this value, the splinter length, which is basically a very extreme noise that is applied to these cutting planes. So these sharp splinters are being generated with this very high value of splinter length. So let me take again a look at the cutting planes and change my visualizers to splinters. So here you see the planes that are generating the splinters. If we decrease the splinter length value, you will notice the splinters will be much smaller. And the splinter density is the amount of splinters that will be generated. Usually we want a large amount of splinters, but it really depends on the size of the wood you're cutting. So just be careful. If you increase this value a lot, you can end up with a lot of detail. So let's try adding a little bit more length. Let's take a look at the exploded view. And again, here the values that you use will greatly depend on the look that you're wanting to achieve. Other than this, there's not much to the wood object. Just remember that, as usual, we will be generating a few groups. You will have the inside polygons, and you will also have a wood cut inside and a wood cut outside group, just in case you want to add UVs or generate particles in your simulation.